Hi, I'm Meryl.
I'm Sadie.
I'm Danny.
I'm Cynthia.
And I'm Lily, and we worked together on the Avondale project this semester.
The City of Durham is planning on building a new large-scale development project called the Durham Beltline Trail. The trail will run through much of Durham, and it's built on top of an old set of unused railroad tracks. We were tasked by the City of Durham with building an entrance or trailhead at the Avondale Drive intersection. The railroad tracks run perpendicular to the bridge at Avondale Drive at the bottom of a ravine. The bottom of the ravine is 25 feet below street level. So our task is to make a way for people to get from street level to trail level that's safe, feasible, accessible, and pleasant.
We made a 3D cardboard model of the area from a topographical map and used it to select our final design solution. Our chosen elevation change solution, wall hugger, starts in the northwest corner of the intersection between the railway and the Avondale Drive Bridge. It is a 12-foot wide, 300-foot long, 6-inch thick concrete ramp with 2 metal railings on each side. It is also ADA accessible with a grade of 1 to 12 with 5 by 12-foot platforms every 30 feet of ramp. It provides a pathway from the sidewalk of the Avondale intersection to the trail below, hugging the side of the ravine as it descends. The top transition is roughly 350 square feet and includes a 6-foot-long bench and drinking fountain underneath a covered seating area, a 10-foot-long bike rack with space for 10 bikes, a sign, and a map. This transition connects directly to the sidewalk to provide a clear and welcoming entrance without putting too much strain on the city budget. The final design solution involves purchasing a sliver from one property so there is room to build the top transition. We recommend to the city that they incorporate a mosaic into the concrete ramp or otherwise imprint designs which will enhance the trail and reference the railroad and/or Durham's history.
We attempted to choose a solution that involved a minimal number of street and bridge crossings, that occupied a corner of the intersection with the most welcoming atmosphere, according to our team members, that left a significant amount of room for future trail extensions, and that adhered as closely as possible to the city budget.
Over the course of the semester, our project evolved so that we didn't meet all the design criteria we established in September. In terms of accessibility, our project met all applicable requirements of the Americans with Disabilities Act, ADA. For environmental restrictions, our project involved making about 8% of the total area impermeable, which is less than the allowed 24%. Safety fell outside the limits of what our model represented. For easy to see and reach from the road, although we believe as a team that this design will fulfill the design criteria, because of its proximity to the sidewalk, we were unable to actually test this. Well lit fell outside the scope of our model. For aesthetically pleasing, similar to our previous criteria, we were unable to test this, but believe that our design will be successful. Minimal regular maintenance fell outside the scope of our model. In terms of amenities, our project includes a trash can, drinking fountain, bench, and a bike rack. Our minimum requirement was 2 out of a list of amenities, so with 4, our final design meets and exceeds this criteria. We also met the available parking criteria. 10 to 15 parking spots are available off-site in the nearby plaza. Our project is also capable of being expanded. Because our design hugs the edge of the ravine, we've left the center open for the path to extend in the other direction should the need arise. Finally, for history of Durham, although our final model didn't have specific references to this, we intentionally left space in our design for it to be incorporated.
We 3D printed a 2-scale pedestrian, and he can be seen walking down the blown-up version of our map. We 3D printed another pedestrian for our smaller 2-scale cardboard topographical map, and he can be seen walking down the ramp.
Our final solution includes the following: a 2-scale model on a cardboard map of the top transition and elevation change in higher detail, a blown-up model detailing the regrading process and railing, and sketches of the final design and amenities. The solution still requires a cost estimation, including regrading, purchasing property, building amenities, and laying concrete, as well as labor and raw material costs. We discovered a few complications while building our blown-up ramp model. With a ramp width of 12 feet, the regrading required produces a steep, almost vertical slope on the uphill side of the ramp, which would be incredibly vulnerable to erosion. Thus, building a successful wall hugger would require the admittedly expensive installation of a retaining wall, or construction of a wooden framework to support a protrusion of the ramp from the side of the incline. We have created a solution that is safe, accessible, and pleasant, and we hope the City of Durham will find our design plan useful as they move forward with planning and construction of the Beltline Trail.